I'm Christina Chang, a fellow at ARPA-E. Phoenix Tailings is an ambitious new clean mining and metals production company based in Woburn, Massachusetts. And they received a seed SBIR grant from us in the 2020 cycle of funding. And today I'm joined by 3 of the 4 co-founders of Phoenix Tailings. Can you explain the origins behind your company's concept? At a high level, how does your technology work?
Let's think about this philosophically for a moment. Right now, we have a vision. We have a vision of a clean, sustainable future with technology that enables it. We want cell phones, we want electric cars, we want wind turbines, but we lack the mineral resources and the technology that enables that at the moment to let that come to fruition. We need to start building that technology. And with ARPA-E, we've taken that first step. We've now started the journey to create the technology that enables this vision of the future.
What we like to think about is twofold. The first, on the high level, is that we look at tailings and believe we can economically separate the bulk material from the tailings, which is usually about iron. It's 30 to 50% of the total volume. You've been doing that process, you naturally concentrate everything else to the point where it's more economic and viable to extract the critical minerals left over, like the rare earths, the platinum, or the nickel. And from the more technical point of view, we really think about our process it falls into 3 categories. The first stage is a concentration stage. We're using hydrometallurgical processes, basically a water-based chemistry system that allows us to separate and refine those different components coming from that tailings. We're able to customize this specifically to the tailings material, meaning that we're able to work with the small particle sizes and the heterogeneous mixtures. The second stage of our process is a separation using solvent metallurgical techniques. This is really using non-water-based chemistries, solvents, and reagents. Separate the mineral-rich streams into intermediate products and form, typically this looks like oxides. So once these materials are separated, we can either sell these as an intermediate product to various chemical or industrial manufacturers, or we can go to our final stage, which is this third stage process called electrochemistry, where we're using our proprietary reduction process to really make the final metal. This is where our core innovation lies. Not that the other stuff isn't exciting innovation as well, but that's really adapting existing technologies towards working with tailings. This is where we're developing new IP to create a process that's able to reduce those oxides or other intermediate products into final metal with no direct carbon emissions, significant lower energy consumption, and no hazardous waste concerns that typically you see in other processes in the industry. So by leveraging all 3 of these stages, we're able to create a portfolio of products, including rare earth metals, directly reduced iron, as well as iron oxide pigments. And critical materials like platinum, battery materials like nickel, copper, cobalt, and precious metals like gold or silver.
So let's dive in a little. What's different or innovative about your approach?
The difference comes about in a couple of different facets. The first one is we're not your typical science startup. We didn't start at a university or some sort of research institute. We actually started looking at the market directly and tried to address the issues that they currently have. And then we also asked the question, why do they do what they do? And one thing we discovered is a lot of these technologies are very, very old, hundreds of years in some cases, maybe with some minor modifications with technology enabling some iterations. But at the same time, they were built in the 18th century, 19th, 20th century, and we've improved a lot since then. Looking at what is available now, and maybe looking at some older methods that previously weren't accessible at those times, but the groundwork was laid, and then layering on top new research, new theories, new understandings of how these chemical mechanisms can occur, it gave us a whole new perspective on how some of these minerals and materials can be treated. The other is that we decided to make a platform. So in making rare earth metals, we may unlock the actual chemistries required to make some of these transition metals like cobalt, like vanadium. And then in doing so as well, we can also tailor it very early on. One of the big things is carbon dioxide and CFCs, chlorofluorocarbons, really, really hazardous greenhouse gas emissions and ozone depleters, among other things. And if you can design the chemistry early on enough, with the foresight that these are going to be major issues down the road, you can create a system that can holistically get you value and avoid future environmental issues.
So your business is based on the premise that it's important to have a domestic supply of rare earth metals. Why is this so important? And why is Phoenix Tailings the company that will help achieve this dream?
There is still a lack of domestic rare earth processing. This is taking the concentrate, which is the mine output, and converting it into the metal, which is the input material into the final magnets. These are processes where you separate the rare earth oxides and then reduce those oxides to the final metal. Additionally, traditional players are limited by their ore bodies. If your deposit is low in heavy rare earths like dysprosium and terbium, which are absolutely critical to magnet performance, you need to get them from somewhere else. This is exactly where we come in. We specifically focus on those two processing stages, separation and reduction, as well as the recovery of rare earths from non-conventional sources like mine tailings and wastewater. We see ourselves as that crucial supplemental supply that allows other folks to acquire the sources of whatever metal that they might be lacking in their deposit, thereby enabling a truly end-to-end domestic supply chain. We produce these metals that are traditionally difficult to make without all the environmental challenges that you might see when trying to implement conventional technologies that are used elsewhere.
Especially for the audience at home that might be interested in applying, could you comment on what it's been like to work with ARPA-E as a small business?
It's been fantastic. The biggest thing that we've gotten from this whole experience is that we've gotten an idea of what it takes to take a difficult project from concept to reduction to practice, and also the impact that it can have. And along the way, feedback, because we're scientists in a sense. It's hard to have a scope of what actually goes on as you try to get more and more industrial. And the timeline and the goals that ARPA-E has helped set with us along the way as we iterate through the project and constantly get feedback in our quarterly reports, it actually enables us to better envision, well, okay, I've made 10 grams, I'm making 100, now how do I make kilograms? Because at the kilogram scale, suddenly this becomes industrially viable.
We've worked with a number of different agencies, all of which have been great. But ARPA-E specifically really feels like they're more part of the actual team, going above and beyond, not to help the business as a whole, outside of the actual project that was funded. We're funded for rare earths, but we were invited to the workshop on green iron and steel making that you organized, Christina. Those kinds of things are fantastic and really help small businesses figure out the different technical and commercialization challenges. The other piece is having the stamp of approval from ARPA-E really helps convey how much the technology has been de-risked to attract funding. That is a crucial piece for a lot of small businesses and startups, and having that sort of approval, as I mentioned, is incredibly powerful when you go out there to get the resources that you need to solve the challenge, whatever it might be that you're trying to solve.
So glad to hear. Thanks for the positive remarks. To wrap us up here, I'd love to hear, what are your long-term goals and vision for the company?
Our goal is to really empower innovative manufacturers by providing them with the materials and the metals that they need in a more sustainable way. And we do this by leveraging unconventional mineral resources while also eliminating this environmental waste.
We can't do it alone, right? We've come pretty far as so far, but we need innovative scientists and engineers to help us scale up and build the next stages of the technology. We need motivated partners on the commercial side who want to lead that transition to a sustainable future. And we need more proactive government folks like what we see at ARPA-E and the other agencies that we've worked with throughout the SBIR process to help us get the resources we need and break down the barriers that exist to implement this full-scale solution.
Thank you so much, team, for joining us, and we wish you the very best success and continued work with ARPA-E.